Okay, welcome to Unit 5 Trig. Our focus in this video is going to be right-angled triangle trig. So we are looking at right triangles. Suppose this is our angle of interest, which we are going to call theta. Well, if our angle of interest is right here, then this is the adjacent side to where our angle is positioned. This is our opposite side, and this is our hypotenuse. Well, from that we have three main trig functions. They are the sine of our angle theta, that is equal to the opposite divided by the hypotenuse. The cosine of our angle is defined as the adjacent side divided by the hypotenuse. And tangent of our angle is opposite over adjacent. The phrase SOHCAHTOA may help you remember those three rules. Keep in mind too that if we're talking about a right triangle, and if we are referring to the sides, we know that a squared plus b squared equals c squared. And keep in mind that we have triples, alright, Pythagorean triples, 3, 4, 5. 3 squared plus 4 squared will give you exactly 5 squared. That's a popular triple to be on the lookout for. And don't forget that sometimes you have camouflaged triples such as 6, 8, 10. I call that a camouflage triple because it's really the 3, 4, 5 triple but doubled. Okay. Three other ones that are popular. We have 5, 12, 13. Be on the lookout for that. 8, 15, 17, and 7, 24, 25. Okay, so if you recognize these four triples, and again I'm not counting the 6, 8, 10 one because that's really a 3, 4, 5 camouflaged. If you recognize those, it saves you some time. Okay, so let's check out an example here. We have in right triangle ABC, they give us some information here. So right away we want to draw this out. Alright, they tell us that B is the right angle. Now it doesn't matter where you put A and B, or A and C, so I'll put my A up there, my C down there. I could have reversed A and C, but B must be the right angle. So A is 34 degrees, and AC, this is referring to the side, that is 6. Okay, we're looking to find BC, so let's call this X. Okay. So if we are positioned right here where that 34-degree angle is, notice that this side of X is really an opposite side, and this 6 is hypotenuse. Well, from up above, we know that the sine of an angle is equal to the opposite divided by the hypotenuse. So we say that the sine of 34 is equal to X over 6. And if I put this over 1 and cross multiply, I'd get X equals 6 times the sine of 34. Now, one annoying thing to be on the lookout for throughout this entire unit is you have to be careful of what your calculator mode is showing you. So right now we are talking about a 34-degree angle, so you have to pay attention to what mode your calculator is in. I know it's annoying, but we're going to be flipping back and forth between degrees and radians throughout the entire unit. So be cognizant of what mode you are in. So here it's clearly degrees, so make sure it's in degree mode. So you're going to enter that in, and it doesn't tell us how to round, so 3 sig figs, as you know, is the general rule of thumb. So that's what X is, so that's really BC, so 3.36 would be our answer. Okay, so that's a quick review of trig. Now, a big topic here is special right triangles. So if we were to look at a special right triangle of 45, 45, 90. This is our first of two special right triangles. Alright, so this is the 45, 45, 90 special right triangle. Well, what makes this special is that if the angles are the same, if you have 45 and 45, it's really an isosceles triangle, so those legs are the same. So if you have equal base angles, we know the legs are going to be the same. Well, let's suppose we call these each 1 and 1. If you were to do your Pythagorean theorem on that, if you were to do 1 squared plus 1 squared equals c squared, you would end up getting 1 times the square root of 2, or just the square root of 2. So what this is showing us is that the sides are in a ratio of 1 to 1 to 1 radical 2. So let me give you an example of how we might use this. So suppose we have 45, 45, 90 triangle. And suppose we know that this side is 6 and we're asked to find the other two sides. Well, because it's really isosceles, this other side must be 6. And sure, you can sit there and you can do Pythagorean theorem, 6 squared plus 6 squared. That's going to give you 36 and 36, which is 72. And if you were to square root your 72, this is really radical 36 times radical 2, which gives you 6 radical 2. You could totally avoid that by knowing that these sides are in a ratio of, like we set up here, 1 to 1 to 1 radical 2. So whatever number you see as your leg is the number that you have in front of a radical 2. So notice the 6, and then 6 radical 2. Okay? So when you have a 45, 45, 90, your sides are in a ratio of 1 to 1 to 1 radical 2. Okay? The next one is a 30, 60, 90 special right triangle. So it's not isosceles this time. So we have 30, 60, and 90. So the side across from the 30, let's call that 1. Well, the hypotenuse is always going to be 2 times that value. Okay? And if you were to do Pythagorean theorem to find this missing side, if you were to do 1 squared plus, call it x squared, equals 2 squared, you would end up getting the square root of 3. So it's really 1 times the square root of 3. So this suggests that if this is 1, then this side will be 1 times radical 3, and then again this is whatever this value is doubled. So a quick example. Suppose again this is my 30, this is my 60, this is my 90, and let's suppose we are told this time that our hypotenuse is 8, and we're asked to find the other two sides. Okay? So knowing that is 8, the one across from the 30 is going to be half of that, because look back up here, we said they're in a ratio of 1 to 2. Okay? So the one across from the 30 is going to be half of the hypotenuse. The one across from the 60, that is going to be, in this case, 4 radical 3. Okay, so again, these numbers match up there and there, okay, from up above. I encourage you to use Pythagorean theorem to prove it to yourself that 4 squared plus 4 radical 3 quantity squared would give you 8 squared. Alright, so we're always checking this by doing Pythagorean theorem. Okay, now the big 3. There are 3 big ones that we want to memorize as a result of this. Okay, so let's grab a different color here. Alright, now these big 3, if you don't have them memorized, you're going to have to reconstruct these triangles. Okay, the 45, 45, and then the 30, 60, 90 triangles. But it's a lot easier to just memorize these. And here they are. So we have the big 3. Okay, these will show up all the time in no calculator sections. They are the sine of 30 is equal to 1/2. So here's my 30. If I were to look at the sine, the opposite is 1, the hypotenuse is 2. Okay. The next one to memorize is that the cosine of 60 is 1/2. If I'm sitting right here at 60, My cosine is the adjacent over the hypotenuse, so that's also 1/2. And the last one to memorize is the tangent of 45. Well, 45, now we're in this other triangle. Tangent is opposite over adjacent, so it doesn't matter which 45 you look at. If you do the opposite over the adjacent, it's 1/1, or just 1. So the big three is that the sine of 30 is 1/2, cosine 60 is 1/2, tangent 45 is 1. If you have to find other things, such as maybe the sine of 60, alright, then you want to recreate your triangle and just look at the values. Alright, if you had to find the sine of 60, well, sine is opposite over hypotenuse, so that would be radical 3/2. Or if you had to find something like the cosine of 30, cosine of 30, well, this is adjacent over hypotenuse, so this would also be radical 3/2. Okay, so if you have to find some trig expressions other than the big three, you want to go back to your special right triangles and just crank out what the answer would be using your trig ratios. Okay, next page. So here's another example. Let's go ahead and draw this picture. Okay, so I drew the picture there. We have our right triangle. B is our right angle. A is 60. And we have side AB is 5. Again, if you flip-flopped your A and your C, not a big deal, but make sure B is the right angle. We want to first find the exact value of BC. Circle this word exact. Well, let's see. Notice this is a 60-degree angle. If that is 60, and if this is a right triangle, then angle C must be 30. So notice that the side across from the 30 is 5. That would suggest that the hypotenuse is 10, because it's a special 30, 60, 90 right triangle. And this x would be 5 times the square root of 3. Okay? So the exact value is 5 times the square root of 3. Then it says to compare to its approximate value. Well, let's use some trig to find its approximate value. So if we're talking about 60, and we're trying to find x, again, let's pretend we don't know it's 5 radical 3, and suppose we were to use this 5 right here. Well, this x is an opposite side, and this 5 is an adjacent side. So we could use our tangent function. The tangent of 60 is equal to x over 5. We could have used a different trig function knowing that the hypotenuse is 10, but let's pretend we didn't know that, and we're only dealing with the x and the 5. So from here I could put this over 1 and cross multiply. So again, make sure you are in radian mode. If we do 5 times the tangent of 60, you're going to get 8.66. That's an approximate value. Now, punch in on your blank screen 5 times the square root of 3. Guess what you're going to get? This is also 8.66. Alright, so 8.66 is an approximate value. 5 radical 3 is an exact value. One more example, and then the application part we're going to do in class. So take a moment, draw this picture, mark it up. Okay, hit pause if you have to. Alright, so do that and then hit play. Okay, hopefully you have that. This symbol, by the way, where you see a little hat over the letter, that just means angle. Okay, angle B, angle C. And then we have our side lengths for AC and for BC. Well, if we have a 45-degree angle here, then we must have another 45-degree angle. Alright, and that means it's really isosceles, and therefore 4x minus 1 is going to equal x squared plus 2. The question wants us to find the least possible value of x and then the exact length of side AB. So let's go ahead and solve this equation. Let's subtract over 4x. Let's add over a 1, so then we're going to have plus 3. equals 0. Go ahead and factor that. So we're going to get x equals 1 and x equals 3. It wants the least possible value of x, so that means x equals 1. This is the least value, so we're really going to reject the 3. Okay, so x is 1, so I'm going to plug a 1 in. Alright, and that's going to give me 3 for this side. I expect to get 3 for the other side. Alright, notice I do. 1 squared plus 2 is 3. So my two legs are 3. I need to find now the exact length of side AB. Well, the long way is to do Pythagorean theorem. 3 squared plus 3 squared, that's 9 plus 9, which is radical 18 after we solve for C. Right, just doing Pythagorean theorem. We break this down, becomes 3 radical 2. Hopefully you're thinking, I'm going to completely avoid that because I know it's a 45, 45, 90 special right triangle, and we know the hypotenuse will have this relationship where you have the leg in front of the radical 3. Okay? So that's it for now. We'll build upon this in class looking at some applications.